This video is about graphing marginal decisions. So we'll start with two definitions. First, the marginal benefit is the additional benefit gained when consuming one more unit of a good, whereas the second definition is for marginal cost. This is the additional cost incurred when consuming or producing one more unit of a good. So in this video, we'll be going over the exercise of graphing these two concepts, marginal benefit and marginal cost, because this graphing will give us a visualization of these relationships. So we're going to begin with marginal benefit. Notice that it ranges from 0 to 10. We'll put marginal cost on that same graph, which ranges from 2 to 12. So we need to be able to fit values that range from 0 to 12. So we'll put that on our axis first. And then we're going to begin with this point of 0 and 10 for marginal benefit. And then we'll do 8 and 1, 2 and 6, 3 and 4, 4 and 2, and 5 and 0. So if you put those points together, you get what's known as the marginal benefit curve. So notice that it's downward sloping or has a negative slope. So this negative relationship is the relationship between the benefits that you get and the total quantity of a good that you're consuming. So each additional quantity is going to give you fewer and fewer additional benefits. So for example, if you were eating pizza, you would expect the first slice to give you a large amount of benefits, especially if you're hungry. The second slice would give you additional benefits, but it would give you less. The third less, maybe the fourth none if you're full. So this negative relationship assumes that our additional benefits go down as we consume more and more of a good. So what you'll see with the marginal cost is that this relationship is the opposite of that. So let's take a look at putting those points on the graph. We start with the point 0. When the quantity is 0, we have a marginal cost of 2. I know that that doesn't make a lot of sense, that you actually have a cost at 0 and actually have a benefit at 0. But notice we're simplifying things. We're going to keep things as simple as possible. We'll use that 0 axis or the y-axis in our curves. And notice I'll also make sure that these are linear. Again, keeping things as simple as possible. So the next point that we'll include is this 1, 4, 2, 6, 3, 8, 4, 10, and 5, 12. And again, if we connect all those points, we get the curve. We're going to call that the marginal cost curve. So notice that it's upward sloping. So this means that there's a positive relationship between cost and quantity, or marginal cost and the quantity. And we assume that with each additional quantity unit that we're either producing or consuming, the additional cost gets greater. So we typically use these curves to explain what we call marginal decision making. And what I want to explain is why it is that we would actually find that we optimize our decision making when we operate where marginal cost equals marginal benefit. But that conclusion has a lot to do with this relationship between these additional costs and benefits and the total costs and total benefits. So let's add that next to our graphs, and let's graph those total benefits and total costs. So total benefit is the benefit that's accruing as you consume more and more of something. So if you take a look at the quantity of 0, we're going to start with a quantity of total benefit of 10. Again, this is a simplifying assumption, but that's what the total benefits we get regardless of the quantity. Now we're going to consume 1, so we're adding 8 more units of benefit. So our total benefit would be the combination of the two. And then for the second one, we would have those 6 units. The third one, we add the 4, the fourth, the 2, and 5. Notice we had 0. So the total benefit would be 30 there. And then to calculate the total cost, we would do the same thing. We're going to add up the marginal costs at each unit, adding the 8, the 10, and then the 12. So our total costs go up to a total of 42. We're going to add these to the graph as well. Notice our y-axis is going to range from 0 up to 42, so we're going to make sure that we can fit that there. And we'll start with the total benefits. Our first point was that quantity of 0. We have a total benefit of 10. We have 118, 224, 328, 430, and 530. So if we connect those, we get our total benefit curve. So notice the total benefits are increasing, but then start to taper off. Okay, that's because those marginal benefits are getting smaller and smaller. Next, we'll add the total cost to this. So our first point is at a quantity of 0. We have a total cost of 2. And then 6, at 2, it's 12. At 3, 20. 4, 30. And then at 5, 42. So notice what the total cost curve then is mapping out is the summation of those marginal costs. The slope of that curve is actually the marginal cost curve. Okay, so when we're at a quantity, say of 1, where notice the marginal benefit is 8 and the marginal cost is 4, or the marginal benefit is greater than the marginal cost, we can increase, we're going to find that we can increase our net benefits, so the difference between the total benefit and the total cost, by increasing Q. Or on the other hand, if we're at a point where the marginal cost is greater than the marginal benefit, like at this quantity of 4, we find that we would actually increase our net benefits by decreasing Q. So this is easier to see if we add that net benefit column to this. So the net benefits turn out to be important here. This would be the total benefit minus the total cost, or the difference between your total benefits and total costs. And we find that we would say that net benefits are maximized at the point where your marginal cost is equal to your marginal benefit. That's our point of optimization. It's the point where you wouldn't want to consume any more or less of something. It's the point, again, where your total net benefits are maximized. I notice here that there's actually 2 points where that happens. That's because of this simplifying assumption. Not only am I working with linear curves, I'm also working with only increasing quantities in whole unit amounts. But if you want to make this more complicated, you could allow for the consumption of partial units. You would need geometry for that. Or we could allow for nonlinear curves, and you would need calculus for that. But you can get the general concept with these simplifying assumptions and with these linear curves. So to sum, the main takeaways are that when marginal benefit is greater than marginal cost, net benefits are increased by increasing quantity. On the other hand, when marginal cost is greater than marginal benefit, you would increase your net benefits by decreasing Q. It's only at the point where marginal benefit equals marginal cost where your net benefits are maximized. Or another way of saying this is that when marginal benefit equals marginal cost, the total benefits are greater than the total cost by the greatest amount. Now, you can think about these rules as similar to the rules of physics. You don't need to understand the law of motion to catch a ball. At the same time, you don't need to understand marginal decision making to optimize your decisions.